This is IGCSE Cambridge physics paper. The paper number is 062511. 45 minutes paper, multiple choice questions. Today we will be discussing only 10 questions from this paper. Later that, with theory, after that we will do the rest of the questions in separate videos. A lump of modeling clay is moved from a small measuring cylinder to a large measuring cylinder that has twice the diameter. Okay, the diameter, this one, let's say the radius of this one is r, this one will be 2r. Why? Diameter is equals to twice the radius. So when this becomes 2, this is a constant. Radius also becomes doubled. Okay. Yeah. The reading on the small measuring cylinder goes down by 20. Okay. So if the reading in the first cylinder goes down by 20, that means the volume of the clay is 20 centimeter cube. By how much does the reading on the large cylinder goes up? So as the clay is only 20 centimeter cube, only 20 centimeter cube, the volume will go up. So the answer is B. Okay. Next one, question number 2. The speed time graph of a train is shown. Okay. Which region of the graph shows the train moving? Here you can see from 1 to 20, speed is 0. Speed, you don't have to think it using the equation, but you can think it logically. When the speed is 0, when something is moving 0 ms minus 1, it is at stationary. Here this is accelerating. Here it's moving with constant speed. This is a speed time graph, so it's moving with constant speed. Here you can see the what do you call this, the gradient is decreasing in decreasing rate, so it is decelerating in increasing rate. So okay, the question, which regions of the graph shows that the train is moving? So Q, R, and S. Answer is B. A man stands to a railway station, to a railway track, to a railway track. A train traveling at 40 ms minus meters per second takes 2 seconds to pass it. What is the length of the train? Okay, here it is a theory. Let's assume the man is the stick and the train is this much longer. So to completely pass the end, this is the end, I'll put an E, and this is the start. So you don't have to think much. If the end comes here, the train has passed him. Got it? The train is moving in this direction. So start passes him. Then once the end passes that person, the train has passed the person. Okay. So that is easy, right? So we don't know the length of this thing, but we know it's moving at 40 meters per second for 2 seconds. It takes 2 seconds to pass the person. 2 seconds to pass the person. You can use the basic equation. Speed equals to distance divided by time. They are asking the distance equals speed into time. Speed is 40 and time is 2. It is 80 meters. So the answer is 80 meters. A spring balance operates by compression of a spring. It has been calibrated on Earth in grams. Yes. Okay. So we have a spring balance. How does a spring balance work? In a spring balance, we have a spring and we have a plate on top of it. So you place whatever the object you want on top of the plate. Depending on the compression of the spring, the scale will give you a reading. Okay, depending on the compression of the spring, the scale will give you a reading. Next one. A beam balance operates by balancing standard mass against the known mass to be measured. Okay, this is a different principle. This is spring balance. And the next one is balancing rod. Okay, wait. Balancing. What is it? The difference is they both use different principles. Here the Hooke's law, we can say Hooke's law is used. But here you can see it's principle of moment is used. Let's say something is moving with x moment, x Newton meter minus 1, sorry, Newton meters, then the other side also it should be with x Newton meter to keep this thing in horizontal level. So no matter, so let's say here it's capital Mg, the mass you are hanging, and this side it's simple mg, the mass you are hanging. So you can see that capital Mg times, let's say the distance is L, and here the distance is capital L into L. For context, moment is found by force multiplying by the distance from the rotating point or the axis. Here the axis is this pivot. Okay, so this is the force. This is in anti-clockwise. So clockwise moment, you can take simple mg multiply by capital L. You can see that g and g cancels. Capital M multiplied by L equals to simple m multiplied by capital L. That means no matter the gravitational acceleration of the planet is not important for this kind of a system to work, this kind of a measuring instrument to work. You don't need gravitational accelerations. Okay. Now let's go to the paper. The gravitation field strength on Earth is greater than that of Moon. Okay, this is not the exact value, but the Moon's gravitational acceleration is 1/6 of Earth. This is Moon's. Okay, don't confuse with mg means mass into. Don't confuse mg means the weight. Moon's gravitational acceleration. I'll erase it. Just remember it's 1/6. How would the measurements on Earth compare to those of Moon? So obviously, if the g on Earth, the gravitational acceleration on Earth is greater, therefore the compression will be greater. So using a spring balance on Earth will give a larger results. And here they say same, so these two are wrong. The answer is A or B, either A or B. Okay, larger on Earth than Moon, yes, correct. Larger on Earth than Moon, second one is correct. Let's go to the beam balance part. Larger on Earth than Moon, yes. Now only we saw that the gravitational acceleration for a beam balance is not important. Okay, cut off. So answer is B. I'll use blue color. The answer is B. A is also wrong. Fifth question. A measuring cylinder contains 30 centimeter cube of liquid. Some of the liquids is some more of the liquid is added until the liquid level reaches 50 centimeter mark. Okay, if it is reaching 50 centimeters, what is the volume added? 20 centimeter cube. The reading on the balance increases by 30 grams. Okay, this is equals to 30 grams. What is the density of the liquid? Okay, this is very simple. You have the volume, you have the mass, you only have to find the density. Density is given by mass over volume. So the mass is 30 grams and volume is 20 centimeter cube. Be careful with the units. Sometimes they will ask in kilogram per meter cube. So if they ask, you have to convert it here, or you can multiply by divide by 1000, or you can solve it later. Okay, that's not an issue. Be careful with the units, but yeah. Now let's simplify. 0 to 0 cancel. 3 divided by 2 is 1.5 grams per centimeter cube. Okay, so the answer is C. Sixth question. A piece of apparatus, which piece of apparatus are the most appropriate for an experiment to plot an extension load graph of a spring? Okay, as the graph says, you need to measure extension and the load. Load is measured in Newton, so you need some sort of a mass measuring instrument, like they say Newton meter. Newton meter means the spring balance. You might have seen it's like this. You hang the weight here and you hang the spring balance onto a ceiling. As the weight pulls down, the reading is given. That's this Newton meter. Clamp understand to hold the what do you call the spring balance. Yeah, so the answer is A. The ruler is used to measure the extension. This extension. Seventh one. This is a little bit off part. I see it's a very easy question, but I saw a lot of people making mistakes in this type of questions. Yeah, let's see. A beam is plotted, a beam is pivoted at one end as shown. The beam weighs 6 newtons and its weight acts on a point x centimeters from the pivot. Okay, it's acting on 40 centimeters. A force of 4 newton is applied to the beam, causing it to balance horizontally. Okay, in which direction and where is the 4 newton force is applied? You can see that if some, you can easily say that if something is moving in this direction, here it's trying to move in this direction. You need to give a force in this direction to balance it. So you can definitely say that the 4 newton force should be given in upwards direction. Okay, it should be given in upwards direction. I'm telling you a way to predict the answer. Okay, it should be given in upward direction. Second thing is, if you go to the equation of moment, force multiplied by distance. Here it is 4 newtons. The weight itself is 6 newtons. As the moment should be equal 6 newton, it should be equal to the moment given by the mass, which is 6 times 40. Yeah, 6 times 40. It should be this value, right? So the moment should be constant to keep it horizontally balanced. So as the force is decreased, the distance should increase. So you can say it should be obviously to the right. Distance should increase from the pivot. So it is in right and the vertically uh, should begin vertically upward. So answer is D. Okay. Now let's use the formula and do. So what is the moment? You can balance the moment. Moment of anticlockwise moment equals to clockwise moment. Here clockwise moment is 40 multiplied by 6 newtons. Anticlockwise is 4, but we don't know the distance. So I will take the distance as here x is used. So we'll use y. 4 and 40 cancels. Here 10, here 1. So if you multiply, it's 60 centimeters. Remember, 60 from the pivot. 60 from the pivot. Here 40 is gone. So here what remaining? 20 centimeters. 20 centimeters to the right and should be acting upwards. So let's say in an instant you can't predict the direction of it. Okay. In that case, if you use the equation, you will get a minus value. So as soon as you get a minus value, tell that the answer is in the opposite direction as you took it. Okay, that's not a hard part. Eighth question. The diagram shows the forces acting on four moving objects. Which object is moving at constant speed? Okay, constant speed means no acceleration, right? Yeah, when something is like this, I'll explain the speed versus time graph. Okay, so when something shows this, it's accelerating. When something is like this, when a line like this is drawn, it's moving in constant speed or constant speed. If I use v, it's velocity. If it is like this, it is decelerating. Okay. Yeah. If the graph bends depending on the acceleration, you can say whether it depending on the direction of the curvature. You can say it's accelerating, decelerating, or something. It's too much for this video, so we'll skip it and we'll discuss it on another paper. Okay. So acceleration is 0. Acceleration is 0. If you come to F equal ma, this is why did I take F equal ma? Because this is the only equation where the force and acceleration are involved. Okay. So in F equals to ma, if a equals to 0, acceleration equals 0, force is also 0. Remember, the force we plot in this type, the force we input in this equation is resultant force. Okay, so you have to find the resultant force, and that resultant force should be 0. Then you can find the object which is moving at constant speed. So in A, upwards 5 plus 3 is 8. 8 newtons to upwards and 2 newtons to downwards. So what is the resultant? 6 newtons upwards. Here 3 newtons upwards, 3 up, 7 down. So obviously the object will move down with 4 newtons. Here 5 up, 5 down, so 0 newtons. This is the answer. D. Remember, once when you see D, cut it off. Why? All of the forces are in one direction. You can't achieve equilibrium while all the forces are acting in one direction. Ninth one. A mass hangs vertically from a spring. The mass is raised to a point P and then released. Okay. The mass oscillates repeatedly from point P to P and a lower point Q. So let's assume this is the ceiling. So the lowest point is, they say, Q, and the highest point is P. So it's moving like this, like a pen. This is a pendulum. Okay. Yeah. Which energies increase? Which energy alternately decreases throughout the oscillation? It's obviously gravitational potential energy, kinetic energy, and elastic energy. Last question, question number 10. A force F acts on an object and the object moves a distance d in the direction of the force. What is the work done on the object? Work done, you have to remember the equations, force into distance. So force is F and distance is d. Answer is C. That's it for this paper. If you have any doubts, you can leave it in the comments. Or if you know my number, you can WhatsApp me. That's it.